This is the lab, determination of the refractive index of a transparent block. Here are the supplies you'll need. You'll need a clear transparent block, a pencil, a piece of paper, a cardboard base, a protractor, and 4 pins. First, you'll take your block and place it on the piece of paper. And the first thing you want to do is take your pencil and trace around the edge of the block. That way, if it moves during the experiment, you can be sure and put it back exactly where it was to begin. For this film, I'm going to use a larger block because it's easier to film. So I'll go ahead and replace that small block with a large block. Trace around the edges. Now what you want to do is you want to take your pins, and we're going to place one pin right at the very edge of the block so that it is touching the block. Stick it into the cardboard, and then take the second pin and place it near the edge of the paper and make an angle with respect to the normal of about somewhere between 15 to 30 degrees. So there we go. And when you look through the block, you'll want to position your eye so that the 2 pins align. So there we go. I've moved my eye so that the 2 pins appear to be aligned. Then, while looking through the block, take your third pin and place it on the front edge of the block so that it too appears to be in line with the other 3 pins, and then do it once more with the 4th pin near the edge of the paper so that you're as far away from the block as you can get, but you're still on the paper. And it helps if you close one eye so that all 4 pins appear to be in a straight line. This is the path the light is taking to your eye as it goes past pin number 1, 2, 3, 4, and then to your eye. So this will tell us the path the light is taking from the first pin into your eye. Once you've aligned the 4 pins, remove the block. And now, with your ruler, you're going to connect the lines. Mark the holes in the paper with your pencil. So there's pin number 1, 2, 3, 4. And now you can remove the pins. The holes in the paper serve to mark the spot where the pins were stuck. And using your straight edge, connect the dots. That's what we've got. And now you'll want to use your protractor to draw the normal. Mark where 90 degrees is, and then draw the normal to the edge of the block. And now this is our angle of incidence, theta I. This is our angle of refraction, theta R. And we'll use our protractor to measure those angles. (10, 20, 30, 40). Looks like 42 degrees on my incident angle. Yes, that's more than 30. I said try and make it between 15 and 30, but I think that's okay. We'll go with it and see what we get, see how our results are. And then my angle of refraction, there we go, 10, 20, 26 degrees. So we'll put our paper down and tape it to the board. We'll place our water dish on the paper. Be sure to trace around the border of it with your pencil. Then take your first pin and place it right up against the edge of the straight part of the dish, the flat part of the dish, right directly in the center. And use another pin to create an angle away from the normal. Then with your eye, find inside the water, not above the water, but inside the water, find the image of the pin and align it with the pin that is up against the plastic. Notice how it is aligned in the water, not above the water. And then using a third pin, put them so that all three, the image, the pin right up against the dish, and the third pin closest to you, so that they all appear to be in a straight line. And now this is the path the light is taking from pin to pin and through the water to the last pin to your eye. You can remove the water dish and connect the pins with straight lines, indicating the direction of the ray of light that is coming to your eye. And there we have our path of light. Going to remove that center pin and mark the normal to that straight edge so that we can measure our angles of incidence and angles of our angle of incidence and our angle of refraction. So there's the normal, and now my angle of incidence is right there, and my angle of refraction is inside the water.